Okay. Hello, can you hear me?
Yes.
Okay. So your questions are, what is the nature of magnetic field in a moving coil galvanometer?
The nature as in?
Hmm?
Nature as in? I don't understand.
Is there any peculiarity of the magnetic field which is there in the galvanometer, moving coil galvanometer?
I mean, it's radial, so
Yes.
coil.
Yes, that's what the answer is. Correct. Next, write one condition under which an electric charge does not experience a force in a magnetic field.
When it's stationary.
Okay, suppose it is good, suppose it is moving, but still it is not.
When velocity and magnetic field are parallel to each other.
Yeah, correct, good. Transformers is there in syllabus?
No, sir.
Okay. What is the formula for radius of a charged particles going UCM in a magnetic field?
MV by QB. R is equal to V.
Correct. Good. Next is in a certain region. What helical motion is there, right?
Yes.
Now you tell me what conditions must a charged particle satisfy such that it undergoes helical motion in a magnetic field?
So when the velocity is in the direction of magnetic field.
Pardon?
The component in the direction of magnetic field.
Can you repeat that answer?
When velocity has a component in the direction of magnetic field.
Very good. Next, a proton and electron traveling along parallel paths enter a region of uniform magnetic field, acting perpendicular to their paths. Okay. I'll repeat, a proton and electron traveling along parallel paths enter a region of uniform magnetic field acting perpendicular to their paths. Which one of them will move in a circular path with a higher frequency?
I think both will move in a circular path.
Both will move in a circular path. That's correct. Which will move with a higher frequency?
Will they both have the same frequency?
No. What is the formula for frequency?
M by 2 pi. Omega by 2 pi.
Okay, what is you decide what is time period, you know radius, you know circumference. From that you can get time period. You do 1 by time period, you can get frequency. So think and answer.
Sir.
Yes.
I've submitted on the classroom.
Okay, okay. If anyone has submitted, please don't ask, just leave. Okay.
Thank you, sir.
Okay, bye bye.
So will proton have a higher frequency?
Why?
Because
see, time period is 2 pi r by v.
yes.
Right? Write this, time period is 2 pi r by v. You know, do you understand this?
Yes.
Oh, r is mv by qb. Put it, you'll get 2 pi m by qb as a time period.
Yes.
That means frequency is 1 by this, inverse of this. So
qb
by 2 pi m.
Because of the smaller, lighter mass of proton.
Electron has smaller mass. Okay.
Yes.
So this one was wrong. Next one is, what is the force force per unit length between two parallel wires carrying current I, having a distance d.
F is equal to F by L is equal to mu naught IAIB by 2 pi.
By 2 pi? 2 pi d. Okay. I am showing you a screen. There is a question. You have to tell me the answer. Okay. This question number 5, which is shown on the screen.
So,
Please submit and leave.
okay.
So is it fourth one?
Is it fourth one?
Yes.
Yeah, it's fourth one. Second. Yeah, it's fourth one. Correct. This one.
So the third one.
Third one. Wrong. Again, you are doing wrong in time period and all that questions. Time period is 2 pi m by qb, right?
Yes. But like so I use 2 pi r by v because it's dependent on v.
Okay, and what about r? The formula which you use is 2 pi r by v.
Yes.
Have you put r? If you put r is mv by qb, then you will see that v cancels. Seventh.
But towards the east.
That's correct. Yes, good. Eighth.
So the first one.
Correct. This magnetic field at the center, okay, due to orbital motion of electron in the hydrogen atom is I need the exact value, okay, not the derivation, the exact numerical value. Okay, what is Bohr magneton?
So it's the minimum value of the magnetic moment of the revolving electron.
Pardon?
The minimum value of the magnetic moment of a revolving electron.
Okay, and what is the value of that? What is the value of Bohr magneton? How much is it? No, you have not gone through the book.
So I
NCERT
don't know
book.
the value of the 10. I know it's 9.27 into 10 power.
It is 9.27.
I mean 9.27. I think into 10 power minus 24.
10 power minus.
Ampere.
I couldn't hear the power which you're saying.
24 minus 24.
And the unit is
Ampere meter square.
ampere meter square. Yeah. Okay, so this is one Bohr magneton. That's correct. So, okay. Fine. What is the value of magnetic moment?
Like the formula.
Yes.
Um,
For a hydrogen atom electron revolving around hydrogen atom.
mu is equal to E by E L by 2 M E. Mass.
H by 2, I mean. H. Oh, you have not studied the book thoroughly. Have you, like, ek bar pura book have you studied?
So,
Book, NCERT book.
yes, sir.
Yes, then you should know these values.
I mean, is it L and the
Oh, you are correct. It is EL by 2. I'm written in the book.
yes.
That's correct. Okay, the notation is EL. Next question is, if the wires are having the same charge, same current, same direction of current, will they attract or will they repel?
Repel.
They have the current in the same direction. Will they attract or will they repel?
Repel.
If they have current in the same direction, they attract. It is opposite of charges. Like charges repel, but current in the same directions of wire
Yeah,
attract.
yes.
You started the VIVA very good. Now you are, every question you are.
3 questions. Okay.
Tell me if there is a solenoid. Okay. Tell me the formula for magnetic field at the in the solenoid.
Mu naught N I.
How will you increase this magnetic field?
So by increasing the current and the number of turns of solenoid.
Anything else? Anything else? Okay. Last question. Okay. You do this. I'm sending in the Zoom chat. Okay. It's a numerical. Do it and tell me. Done?
No, so I'm not getting it.
Getting it. Not good. This is supposed to be easy one. I am giving you a link, okay? To all the questions in this link. Okay. And you should have got this question. This is easy. I'm giving you long numericals. This was easy numerical. You do all the questions in this link, okay?
Yes, sir.
And especially the numericals you have to send me. Write and send me, okay?
Okay.
Any numerical is there, you write and send me. Fine?
Yes.
Leave. Bye-bye. Study well. Questions, okay? What is the formula for radius of something which is revolving in a magnetic field? Radius of the UC.
QB by MV.
Say that again.
QB by MV.
I heard for the first time, but you are wrong. That's why I said,
MV by
say that
QB.
again. Yes. Okay. Next question. A beam of particles. You can use a pen paper if you want. Okay.
Yes.
A beam of particle is projected along x-axis. Okay.
Yes.
Alpha particles. Okay.
Yes.
So it is going towards plus x-axis, and it experiences a force due to magnetic field in the plus y-axis.
Sorry,
Okay.
so your voice broke. You said force due to magnetic field.
In the plus y-axis.
Yes, sir.
I'll repeat. The particle is going along the plus x-axis. It's a positive charge alpha particle. The force experienced is in the plus y-axis. What is the direction of magnetic field?
Like in vectors or?
Just the direction of magnetic field. You can tell in terms of axis in which.
Plus z axis.
Are you sure you have made the diagram? I'll repeat.
Yes.
The velocity is along the plus x-axis. The force experienced is along the plus y-axis. What is the direction of magnetic field? What concept have you used?
Just the right hand thumb rule.
Okay, explain a little bit more.
So can I do it again?
Yeah, do it again.
Sir, I submitted the paper. I see.
Yes, I think it should be plus z only.
Can you explain how is it plus z?
You keep your hands in the direction of the magnetic field, and then
In which direction is the magnet? From where? Which vector to which vector do you curl your hands?
from x, like that.
Okay. Okay. You are using a cross product.
Yes, sir.
What is the formula for force? Equation relating force, velocity, and magnetic field.
QBB.
QV cross B.
Yeah.
So V cross B is force.
Yes, sir.
I have given you direction of V and F, not V and B.
So, sir, I'm not sure how to do it.
Okay. Okay. Fine. Next question is, A charged particle is moving in a magnetic field, but it does not experience any force. Why? What could be the reason?
Uh, the it's uh, it's anti-parallel or parallel and not perpendicular
To what?
to the magnetic field.
What is it? Is per parallel or anti-parallel? What is it?
The force.
Force. You need to study. Your answer was correct, but its velocity is parallel or anti-parallel to magnetic field. Which will, if everything else is same, okay, everything else is same. I mean, an electron and proton, which will have a larger radius in a magnetic field. In the same magnetic field, everything is same. Just the velocity is same. There is one electron and there is one proton, which will have a larger radius.
Proton,
Why?
because the mass is higher.
Proton mass is higher. What about the charge?
The charge for proton is positive and electron is negative.
R is mv by qb. So mass of proton is higher, so it will undergo more. The radius will be more.
Yeah.
Right? Okay, this is correct. What is the force per unit length between two parallel wires?
Like the formula,
Yes.
mu naught by 4 pi IAB by 2R into L.
Yeah. Repeat the formula.
Mu naught IAB by 2 pi D into L.
I asked force per unit length. Why are you multiplying it by L?
Oh, sorry, sir.
So I submitted, sir. Can you leave?
Yeah, fine. Bye bye. We leave.
Thank you, sir.
Next is what is state the vector form of Biot-Savart law?
Mu naught by 4 pi IDL R cap divided by R cap cubed.
Repeat.
Mu naught by 4 pi IDL R cap divided by R cap cubed.
You didn't say cross product.
Oh, sorry.
Either you have to say a cross product or you say sine theta. You skipped both.
Oh, sorry, sir. I'll say it from next time.
What is a magnetic field inside a toroid?
0.
What?
0. Inside the toroid, it's 0.
Okay. In the cylindrical portion of the toroid, what is it?
Mu naught I by 2R.
No, it is mu naught ni.
So how is it mu naught? I thought it's mu naught.
Do you have the NCRT PDF
No, sir, I have the textbook.
textbook? Okay, open toroid. Have you seen?
Yes, sir.
It's mu naught Ni, okay?
Yes, sir.
You need to study a lot.
I'm sorry, sir. I did a lot of last minute things.
Yeah, you did a lot of last minute
Like last minute study.
preparation, okay?
Yeah.
If two wires are having same direction of current in the same, I mean, carrying in the same direction, will they attract or will they repel?
Sorry, sir, your voice broke.
If two wires are having current in the same direction, will they attract each other or will they repel each other?
They'll attract each other.
Good. Okay. I am showing you some questions. Okay.
Yes,
You
sir.
have to answer them. Fine.
Yes, sir.
Sixth.
T by 2.
E by 2. Have I given this
Sir, I submitted.
exercise as homework already? But yeah, leave Tolika. Have I given this exercise as homework already?
Sir, I don't remember. I'm sorry.
Okay. See the link name. Now do you remember?
Oh, yeah. I think you've given the other ones like 35 or something.
Okay. I actually told to do everything from this. This answer is wrong. It is wrong because time period of formula is 2 pi m by qb. Okay, that is wrong.
But sir, if the velocity is 2 times, then the time period should reduce by 2 times, right?
Why?
Because the formula.
बोलो क्या है formula?
QB by 2 pi.
This is the formula for time period, right?
Yeah.
It is 2 pi m by qb.
No, sir, I was talking about velocity.
The formula for time period is 2 pi m by qb.
Yes, sir.
Is there any velocity in this?
The velocity is 2 times.
I'll repeat. The formula for time period is 2
Oh,
pi
yes, sir.
m
In
by.
the in the formula, it's not there.
It is independent of velocity.
Yes, sir.
Next, seventh. This is easy one. Don't get it wrong.
East.
Yeah, correct. Eighth.
Three by 2 r squared pi.
Option 3.
Yeah. So I'm not sure about how to do this one. Can you explain it?
It is area into current of this minus area of current into this. This area is half into pi into 2r square,
Yes,
the
sir.
lower area.
Yes, sir.
Half into pi into 2r square is 2 pi r square.
Yes, sir.
And the above area is half into pi r square. And these currents are opposite in direction. See, this is lower mein. In the upper it is, no, they are both are clockwise, right? So they'll add up. Okay,
Yes, sir.
they'll add up. You said 3
So
by 2
if it
because you
was
thought,
so if it was opposite, you would subtract it, right?
yes, which you did by mistake.
Yes.
But they are in the same direction. Both are clockwise. So they'll add up and become 2.5. Okay, so I'm giving you one last numerical to do. Okay.
Yes. Do I like need this?
You use pen, paper, pencil, whatever.
Yes.
See the Zoom chat. I have sent you a question. Do that, okay?
Like right now, right?
Like right now, yes, it is in your VIVA, okay?
Yes.
Rupak,
Yes, sir.
okay. So
Yes, sir. Can you hear me? Yeah, okay.
yeah, the questions are: first, a charged particle is moving in a magnetic field, but it is not experiencing any force. Why?
Force is into
Oh, I'm not expecting you to take so much time in this.
so I forgot force.
A charged particle does not suffer any deflection while passing through a region of uniform magnetic field. Why is it so?
One second.
There is Q, there is V, and there is B, but still there is no force. Why?
QVP.
What is the vector notation? Vector form of this formula, which you just said. What is the vector form of the formula which you just said?
One second.
Speak louder.
QVB. QVB sin theta.
Yeah. So why could it? Why the force could be zero?
Sin theta would be 0. Theta would
Why? Because theta is zero. The velocity is parallel or anti-parallel to the magnetic field. This is a simple question. First question also you are doing this. Next, a beam of protons is projected along the plus x axis. Okay,
yes, sir.
make a diagram if you have to. Beam of proton is projected along the plus x axis and experiences a force in the plus y axis. Okay, what is the direction of magnetic field? Do you want me to repeat the question?
One second. I can do this. So I think it's +5.
I'll repeat. The beam is projected along the plus x axis.
Yeah.
The force is along the plus y axis.
So axis
In which direction is the magnetic field?
is Z.
Speak louder.
Yeah, is it? Can you hear me now?
Yes.
Okay, so is Z axis the will be K cap into J cap
K cap. You have to tell me a direction. You
minus
can either tell me in ijk or you can tell me in plus x plus y
Minus-
plus z or minus
minus Y.
minus y.
Yeah,
What are you doing? I mean, are you studying this chapter? Have you studied this chapter or not? I said velocity is along plus x, force is along plus y. How can magnetic field be also in plus y? It has to be perpendicular to both.
so it's K cap.
I can't hear you.
So it's K cap. So it's K cap
Which k cap? Plus k cap or minus k cap?
plus K cap.
No, it is minus k cap. You have not studied x, y, z. Yeah, it will be minus k cap. V cross B. V is plus x.
Yes,
B
sir.
I'm asking you. Force I've given you plus y. So B must be in minus z. What is the peculiar thing about the magnetic field inside a moving coil galvanometer? Is there any speciality?
So in a moving coil galvanometer,
The magnetic field.
magnetic field is NIAP. So it's torque NIAP. Yeah.
Oh, sir, I'm done. So should I send it to you?
You tell me directly the answer, okay? Just the one word answer of both.
Oh, yes, sir. Resistance of shunt I got 0.2 ohms,
Okay, and total resistance
0.16
0.1
ohms.
second, okay? Okay, you send me the answer, okay?
Yes, sir. So I'll WhatsApp it, right?
Yeah, that's correct. That's correct. You can leave, okay? Aditi.
Thank you, sir.
Yes, Rupak, I asked you what is the peculiar thing about the magnetic field in a moving coil galvanometer.
Yeah, the torque is NIAV. So,
Okay.
so K5 is also NIAV. Yeah.
Okay. Is there anything special about the magnetic field? Have you studied this chapter from the book? Have you read the book once?
I read the formulas from the book.
Pardon, you have read the?
I read the formulas from the book.
Not, you have not read the book like.
No.
Tell me Biot-Savart law in vector form.
Nu naught by 4 pi is equal to I TL by R. D vector L length into R by R square.
Speak that again.
Nu naught by 4 pi into I into DL into DR by R square.
What is this formula for? What is the left side of this formula?
What?
You are not audible. You whatever device you are using, you use it properly.
Yes, so can you hear me now? Yeah.
Yes.
Okay. I said nu naught by 4 pi is equal to I DL DR by R square.
You said mu naught by 4 pi is equal to ideal.
Nu naught 4 pi into IDL into I nu naught by 4 pi into IDL into DR by R square.
What is this formula for?
Magnetic field of a carrying wire.
So left side is B. Okay.
Yeah.
You are almost correct, but I asked you in vector form.
Nu naught by 4 pi into IDL.
Again, your voice is gone.
Okay. So now nu naught by 4 pi into IDL sine theta by r square.
Okay. Actually, when it should be, you should say ideal cross r by r cube, because when you say ideal sine theta, that means you already have broken down the vectors and then you're now writing ideal sine theta. That means now your I and dl are ideal are scalars. Okay.
So you have to say r vector and r by r cube.
Sai Sham join exactly at 1. Okay. Rupak, tell me this answer. 5th.
It is distance. I think it's 4.
Correct. Two.
Speed up.
Speed up.
Yeah.
Correct. Third. Okay, time's up.
Wait, so can I tell you an answer which I got?
No, you tell me 6th.
Okay. T, so T4.
No, correct. T is correct. 8th.
Three by 2.
No, that's wrong. It's 5 by 2. They will add up. The current is in the same direction, clockwise. It's 1. C.
Yeah, okay.
Rupak, I'm giving you one last question.
Yes, so
Numerical. You do it. Okay, and tell me the answer. Okay.
okay.
It's in your Zoom chat. Hello, Sai, video on.
So can you see my video?
No, I can't.
So it's on only, so I don't know why it's not showing.
Figure it out.
So can I rejoin?
Yeah.
So can you see me now?
No, you can join through phone or something if.
I'm using a
Another
different device because my brother has my laptop.
Okay.
So can I write the questions down which you're given when you're telling me?
No, it's anyway oral exam, so I'll just listen and
Okay, sir. No problem, sir.
okay. What is peculiar about the magnetic field inside a moving coil galvanometer?
I'm sorry, what?
What is peculiar thing or special thing about the magnetic field inside a moving coil galvanometer?
It's a highly sensitive instrument.
No, you are telling me about the moving coil galvanometer. I'm asking you about the magnetic field which is produced, which you give inside a moving coil galvanometer. How do you give a magnetic field inside a MCG?
By presenting a charge inside it, which will then react with
Say that
the.
again. Repeat.
You put a charge inside the moving coil galvanometer, which will then.
No. No. What is the concept of moving coil galvanometer?
It's like used to present. It's like used to detect the presence of a current in a given circuit.
How does it work? Simple, 2 lines. That's correct. It uses detect.
It's like shows no deflection. Like
if there is no current.
Like if it's connected to a Wheatstone bridge circuit, then it will show null deflection. Basically, no current flows to the device.
So what happens when current flows? Why does it show deflection?
So because it encounters a magnetic field, which will then show deflection in the compass direction.
According to which law is there a deflection? Why is there a deflection?
There's deflection because Lorentz force.
Yes, that's correct. Lorentz force. Okay. You know, approximately 60% of moving coil galvanometer.
Okay.
But you have to study. A charged particle is moving in a magnetic field, but it does not suffer any deflection. Why?
A charged particle is moving in a
magnetic field.
Okay, sir.
But it does not suffer any deflection. Why?
It does not suffer any deflection because because it is not close. It's not close to this one, the charge, or the charge particle is not moving around. It
is moving. That could be correct. It is not moving, but it is moving. I'm telling you, it's moving.
So then the charge, the circuit's not on. Like the switch is not on.
There is no circuit. There is a charged particle. It is moving in a uniform magnetic field. There is a magnetic field. It is moving in that.
Okay, sir.
But it is not having any deflection. It is not experiencing any force. Why?
So because it's not close to the particle.
First, okay. Why should it experience force first?
So it should experience force.
According to which law?
The Biot-Savart law.
No, not Biot-Savart law. It is Lorentz force.
Okay, sir.
QV cross B.
Sir.
So there is Q, there is V, there is B, but it is not experiencing any force. Why?
Magnetic field. Velocity, it's moving around.
Moving?
So it's moving, the charged particle is moving around. The magnetic field is there. There is velocity, but
Force is
so it's
zero.
not encountering another charge which will either repel or attract it.
So I finished.
You tell me one word answer of the questions. One word. Final answer, quickly. Rupak.
Oh, so it was 0.2 ohm for the shunt resistance and total resistance is 0.16 ohms.
Okay, bye. That's correct.
Yeah, okay, thank you, sir.
Sai Shyam,
Yes, sir.
I have given you link in the Zoom chat, okay?
Okay, sir.
You have not studied well. Abhi I'll ask you more 1 second.
Okay, sir.
So first thing you will do is all the link, is link mein jitna bhi questions hai, okay, all questions, okay?
Yes, sir.
You have to write and send, okay? Answers,
Okay, sir.
not questions. Okay?
Okay.
Okay. Next thing. Tell me the answer of question number 5 on the screen, the question shown on the screen.
Are you presenting something?
Yes, on the screen, can you see?
Yeah, sir. 1 minute, sir. Oh, will it be 4?
Yeah, that's correct. Sixth.
1 minute, sir.
One second. Yes.
So 1 minute. I have not properly read the question again. So 2t.
That's not 2t. Time period is independent of velocity.
Okay, sir.
Seventh.
So is it east?
Yes, it's east.
Okay, sir.
Eleventh.
So will it be 2, a circle in the XZ plane?
Yeah, correct. Next question.
Yes, sir.
Right. Tell me the relation between deflection and torque in a moving coil galvanometer. The relation between deflection theta and torque.
So the deflection in the coil of a galvanometer is directly proportional to current flowing.
I asked torque.
Oh, so like the torque that acts on the coil, right? It's suspended in the uniform magnetic field. So due to that, the coil rotates. Therefore, the deflection is directly proportional to the current flowing in it. So torque is also directly proportional to, sorry, the
That's good.
deflection is directly
Good.
proportional.
Good. What is the definition of magnetic moment and its unit?
So
If you don't know the
magnetic,
definition, you can tell me the formula also.
so magnetic moment.
Yes.
So it's T is equal to, no, the tau is equal to M into B.
Why are you saying tau and all? Magnet tau is torque. I'm asking you magnetic moment.
So that's the formula, sir.
That is formula for torque on a magnetic dipole in a magnetic field. That is formula for torque, what you're saying. Or you're saying
Yes,
torque is M cross B.
Yes, sir.
I'm asking you magnetic moment specifically. What is magnetic moment ka formula and what is its unit?
So can I tell you the definition?
Okay.
So it's a measure of the torque exerted on a magnetic
No.
system.
No. There should be no use of word torque in the definition of magnetic moment. Are you sure you don't know what is magnetic moment? Because it's a very basic thing. What is the unit of magnetic moment?
The Newton meter.
No. Magnetic moment is NIA, simple. N number of turns into current into area of a coil.
Right, sir.
And its unit is ampere meter square because I into A. What
Right,
is the, you have to study, man, you are not studying. Why is that so? What are you doing in your time? After
I
class.
have exams in school, so that's why.
Exams may they are asking this, right?
No, sir, I didn't have physics up to now. Like they're keeping other subjects, that's why.
No, I'm asking in general. Maybe in the last 10 days or 15 days, you have had a physics exam, right?
So yeah, but it was like from the first chapter and all. I haven't
First chapter,
come to.
specifically which chapters were there?
So no, sir, it's just like they just come, they give us a test and they go away. Like, they don't have a specific this one.
But they were, has chapter 4 been asked in the last 15 days somewhere or not?
No, sir, we haven't done it in school yet. We have to finish this chapter only.
But I have taught it and
Yeah,
should be
sir.
knowing these answers.
Yes, sir.
You do this numerical, okay?
Okay, sir.
I'm sending in the chat.
Okay.
Okay, Anushka,
Yes, sir.
video on. Anushka, what is the formula for radius of some charged particles going in a magnetic field?
Radius of a charged particle moving in a magnetic field.
Yes.
R is equal to B into 4 pi by mu naught.
No.
Wait, like radius of the path of the particle, right?
Yes. Yes.
I don't know.
It is mv by qb.
Oh, right, yeah.
Question number 5.
It's 1.
Oh, I didn't expect you will do this wrong.
Wait, no, sorry, it decreases. So it's 3.
It's 3.
Yeah.
What is the formula for a magnetic field induction at a distance d due to thin wire carrying current?
Mu naught I by 2 pi R.
What do you think this graph will look like, B versus R?
As R increases, B decreases.
Okay. Is it inverse proportionality?
Yes. Oh, so say 4.
4, yes. Is 6th.
And 4T, right?
Pardon?
4T.
No. Time period formula is 2 pi m by qb. Velocity is it is independent of velocity.
So,
It is only dependent on charge to mass ratio.
Oh,
So the answer is T, option 4.
so
7.
on the,
Once again, Saisham, have you done that?
yes, sir.
What is the answer?
So 0.2 ohms and 0.16 ohms.
Okay, that's correct. Bye bye. Yes. 7. It's easy here.
so I'm confused about like the horizontal component.
Horizontal component of Earth's magnetic field is towards north.
Oh, okay. So won't it be anti-parallel then, the positive charge in the magnetic field?
You use your right hand rule, QV cross B, the velocity is towards vertically downwards, the magnetic field is north. If you do V cross B, the thumb will point towards the east. East is the answer. Eighth.
Um, 3 by 2 pi r square I.
Why are you saying 3 by 2? Did you add the individuals or subtract the individuals?
Add.
If you add, then what is the dipole moment of the lower half?
I into pi r and pi 2r.
Repeat.
I into pi 2r pi 2.
Pi. What is the formula for dipole moment?
I into a.
What is A?
Pi r square.
What is A? I mean, what is A in general?
It's the area of the
Loop. What is the area of the lower loop?
pi r.
Pi r is the area of the lower loop. What are you saying?
Like because it's half of a it's a semicircle.
So semicircle का area is pi r.
No, pi r square.
What is happening here? Tell me clearly. Tell me the area of the lower half. Very simple question I'm asking you. If a semicircle of radius r, what is the area?
Pi r square by 2.
Yes, the radius here is
2r.
So what will be the formula now? What will it become?
Pi 2r. Oh, sorry, yeah. So it'll be pi 2r square.
Pi into
2r square.
2 pi r square.
Yeah.
What is the area of the above loop?
Pi r square by 2.
Will these two things be added up or subtracted?
Subtracted.
Are the currents in the opposite direction or the same sense in the loops?
In the same direction.
Then they should be added or subtracted.
Added.
So what is the answer?
5 by 2 pi.
Yes, 5 by 2 is the correct answer. That means you haven't done these. I have told in the class to do these questions. How about 57?
Will it be 0?
Yes. It is 0. It is 0, correct. Next question. See, you need to study. What you need to do is, I am giving you a link. You need to write all the answers of this. Okay.
Yes, sir.
This is not okay. Okay. Two more questions. Okay.
Yes, sir.
What is the concept of a moving coil galvanometer?
A coil is suspended in a free space, and when it has like a pointer connected to it, and it's in a metal frame, and the current passing through it, it like deflects the pointer.
If it deflects the pointer, if
there's current passing through it.
okay, what is the underlying principle of according to which formula it works? What is the underlying physical equation or formula on which MCG works? Okay. Basically, it moves the pointer because of magnetic field, current in a magnetic field, right? So it is moving charge in a magnetic field. Moving charge is experiencing a force in magnetic field. It's basically Lorentz force. Underlying principle is Lorentz force. What is the equation connecting torque and magnetic field of MCG?
Torque and magnetic field.
It's a famous equation. How much time have you devoted to prepare for this VIVA?
I did it all of yesterday, and I'm just forgetting everything.
See, it's not some language you'll do it day before yesterday only, and then you will get it. You will. How will you remember if you have done it yesterday only, and then you expect to cram everything up?
I did it over this week, but I'm just.
Torque is NIAB. Tau is NIAB. It's a famous equation. Cyclotron is there in the syllabus or not?
No.
Okay. Electron and proton are everything else is same. Okay. An electron and proton enter a magnetic field with the same velocity. Everything is same. Everything else is same because just that one is electron, one is proton, which will undergo a circular path with the greater radius.
The proton, because it has more mass.
Why? Okay.
Because it has more mass.
Correct. What is the magnetic field? Slowly I'll ask. Okay. The magnetic field due to a circular loop of radius A carrying current I, only one loop. Okay. If you want to make the loop, make the loop. So there is a circular loop.
Yeah.
One circular loop carrying current I, having radius A. Okay.
Yes,
I want the value of magnetic field at an axial point. You know the axial point?
Yeah.
At a distance x.
Okay. It's just the. Um, it'll be mu naught I a square by 2 into x square plus a square whole power 3 by 2.
Very good. Very good. This is correct. What is the magnetic field inside a solenoid?
And mu naught n I.
What is N?
N is the number of turns of the solenoid.
Are you sure? What is N?
Is it n like number of turns by 2 pi r?
It's number of turns per unit length.
Yeah, sorry, number of turns per unit length.
Last question. This numerical, okay. In chat.
So one is the resistance of the shunt is 0.2 ohm, and the equivalent, like the combined resistance of the two is 0.16 ohm.
Yeah, that's correct. So that means you are okay with shunting and all that, right?
Yes, sir.
For the basics of the chapter, you are not okay.
Yeah.
Especially the radial, the magnetic field, the motion of charge in magnetic field, and then also force between two. Okay. If the two wires are carrying current in the same direction, will they attract or will they repel?
They will attract. It's a parallel thing.
Okay. 1 second, okay.
So,
Yes, Saksham. Yes, yes. Oh wait, I have not that in written. Your timing was still 1:30. Okay, fine. Okay, fine. You can leave, Anushka.
okay, thank you, sir.
Bye bye. Okay. A charged particle goes in a magnetic field.
Yeah.
Is moving in magnetic field, but it is not suffering any deflection.
Yeah.
Why?
Because the electric force and magnetic force is the same.
Okay, I'll repeat my question. There is no electric field.
There's no electric field. Okay.
A charged particle is moving in a magnetic field, uniform magnetic field.
Yeah.
But it is not suffering any deflection. There is no force on the charge. Why?
Wait, what particle is going in it?
Any charged particle.
Any charged particle. Okay.
Yes. What is the force? Which equation? Tell the equation which gives you the force when a charged particle is moving with a velocity v in a magnetic field.
Q is force equal to Q V cross B.
Q v cross b. So there is Q, there is v, there is b, but still there is no force. What could be the reason?
There's Q, there's V, there's the angle between the velocity and magnetic field is 0.
Yes. So
Yeah.
we say v is parallel to b.
Yeah.
The radius of a charged particle when it goes in a magnetic field, the UCM ka radius, what is the formula?
UCM, like,
The circular motion it performs is UCM.
yeah.
The radius of that circular motion has a formula.
Oh, I need to write this down
Okay, you write
to
this down.
derive it quickly. What do I have to find?
Radius formula R.
QB by MV.
It is opposite of that, reverse of that. MV by QB.
1 second. Oh yeah, it's MV by QB, my bad. Yeah.
There are two infinitely long straight wires carrying current I1 and I2 and separated
Yeah.
by a distance d.
Yeah.
What is the force per unit length between them?
Mu naught I1 I2 L by 2 pi d.
There is a slight mistake. I have asked force per unit length.
Oh, take L down then. So the L will go to the other side.
Yeah. If the currents are in the same direction, the force is attractive or repulsive?
Attractive.
Correct. How can you define 1 ampere of current based on this concept?
1 ampere on this concept.
Yes, based on this concept, how will you define 1 ampere of current?
Can I use the V is equal to I into R formula and define it?
No.
Yeah. I'm just writing the formulas. Can you just repeat the question again? You have to define 1 ampere of current in this concept.
Yes.
Oh, do I have to use the force equal to I L cross B formula or something?
No, same formula.
Which the Biot-Savart's law formula?
Same formula which we just discussed.
Okay, which one did we just discuss? The QB by MV.
I1, I2.
Oh, okay. I'm not sure.
Okay. You need to study the chapter again.
Okay.
Tell Biot-Savart law in vector form.
In vector form.
Yes.
Normal form is mu naught I by 4 pi I dl cross r by r cube.
This is vector form
Okay.
because using a
I
cross
realized,
product,
yeah. If you do cross product, r will get cancelled, yeah.
Tell me one peculiar thing about the magnetic field in a moving coil galvanometer.
What do I have to tell?
One peculiar thing about the magnetic field used in MCG.
Peculiar thing.
Yeah, what is special thing about it?
About the magnetic field.
Yeah,
I'm
how
not
is magnetic
sure.
field obtained in a MCG? What do
Is
you
it
use?
is it how the shape of the magnet is cut for
The
the
what shape is it in?
galvanometer? It's that U shape.
So what kind of magnetic field does it produce? There is a special word for it. You really need to study the book again if you have not done it.
What is the name?
Radial.
Oh, I was gonna say circular.
Question number 5.
Four.
Correct. Question number 6.
Let me do this 1 second. Is it 3?
No, it is not 3.
1 second.
7th.
Is it north?
No, it is
No, it won't be north. No, it'll be
8th. You can speak out what you're thinking.
okay. So along the straight paths, there'll be no magnetic dipole moment.
Hmm.
It's only along the 2 semicircles.
Hmm.
Now the magnetic dipole moment's formula is NIA, but N will be 1, so it'll just be IA.
Yes, correct.
So now here you will have to put the value of A as half pi r square for each semicircle,
Yes, correct.
and then add it.
Add or subtract?
Add it only.
Very good. That means you'll be able to do this. What is the value of one Bohr magneton?
Oh, I'm not sure. I know it's where in the book. I don't remember it. It's 9 point, I think 9 point something. Something like that.
Question number 13.
Out 10 ohm.
10 ohm.
Yeah.
Correct. Good. 14th.
It does also particle in the plane of paper. Is it a proton?
Did you guess or there is some
No,
logic?
I'm not sure.
It's a proton. Fifteen.
It's just half into NIA. But wait.
Answer.
Okay.
No, I want answer. Ritvik,
Yes, sir.
video on. Rohan, have you seen the question? Have you noted down the values?
Yeah.
Note down the values. I'm stopping share. Okay.
Okay. Wait. Oh wait,
This
one
is your
second. You
last
go back.
question, Rohan. This is the last question.
Okay.
You tell me the answer and leave. Okay.
Okay. 850 meters then. Yeah. Okay.
Okay, Ritvik.
Yes, sir.
Hi. Formula for radius of a particle going in a magnetic field. Charge particle.
MV by QB.
Good. When
Oh,
does
it's
a
C.
charge particle follows numerical value bolo?
1 point. Wait, can you show me the values again? 1 second. And I'm gonna check if it's rounded off. I got 32. Yeah, at 33.1 something.
That's wrong. Did you
Wait 1 second.
did you take into account mu naught, which value is 4.2 10 power minus 7?
I think I took the wrong value of mu naught.
Okay.
Yeah.
Don't take wrong values of mu naught. Fine, you can leave.
Fine. Thank you.
Ritvik.
Yes,
Yeah,
sir.
when would a charge particle go helical motion?
Helical motion. So it travels in helical motion regularly because there's a when there's a linear magnetic field and a circular magnetic field.
Circular
So
magnetic
normally,
field.
so when the magnetic field is perpendicular to the plane, then the particle will travel in a what do you call circular path, and
Yes.
because of the magnetic field, the force is pushing the particle a little forward, so it travels in a path.
No. First part is correct. If there has something to do with the direction of velocity, think on that terms.
I'm not too sure.
When the velocity has a component in the direction of magnetic field, then it undergoes a helical path.
Component in the
Okay.
direction. So either like v sin theta or v cos theta is in the direction of the magnetic field.
Yes.
Okay.
Next question: if there is everything else is same, and an electron and a proton enter a magnetic field at perpendicular, which will undergo a circular of larger radius.
Larger radius, the proton.
Why?
So because now electron has negligible mass, whereas proton has an actual much higher mass.
Good, that's correct. That's correct. Good. What is? Tell me Biot-Savart law in vector form.
So Biot-Savart vector form will be ideal cross r by r cubed. Mu naught by 4 pi ideal cross r by r.
What is the left side of this equation?
So left side is the magnetic field.
Okay, good. A charged particle is going in a magnetic field, but it is not suffering any deflection. What could be the reason?
It's not suffering any direction. It's because the velocity of the particle is equal to the electric field by the magnetic field. That's value.
I'll repeat my question. The charged particle is going in a magnetic field. There is no electric field.
Oh, okay. So the charge was moving in a magnetic field. There's no deflection. So I mean the force on the particle is 0. So this thing v cross b will be 0. So it will be
Yes.
parallel to magnetic velocity. Velocity of the particle will be parallel to the magnetic.
Very good. It's parallel or anti-parallel?
Anti-parallel.
Good. What is the force per unit length between two parallel conductors carrying current I1 and I2?
It will be mu naught IA, which is the first conductor, IB, by 2 pi d into L. L is the length of the conductor.
Force per unit length.
First per unit length. So then remove the L won't be there.
Okay, good. How will you define 1 ampere from this?
1 ampere is the current flowing through each of the parallel conductors when the force between the first force on each conductor by the other conductor is equal to 2 into 10 to the power 7 Newton meters, and they're separated by 1 meter in vacuum.
Very good. Excellent. If there is a circular current carrying loop having current I, radius A, just one loop. Okay.
Yes, sir.
What is the value of magnetic field at an axial point, distance x from the center?
X from the center, it will be mu naught I into R, which is A, by x squared, which is the distance from the distance of the point.
You can take 1 minute time, right? Make the diagram, write the answer.
Okay. So could you repeat
and
the
then
question?
tell me the answer. There is a circular loop of radius A carrying current I. I want the magnetic field at a distance x from the center of the loop at an axial point on the axis. Can you show what diagram you have made?
So there's a point. So 1 minute. This is how the diagram.
Can't see properly. It's very white.
So 1 minute.
Yes, it looks correct. I'm not able to see your the markings, but yes, it's correct. Yes, at point P, what is the magnetic field?
Point B, okay. Um, so 1 minute. So it will be mu naught IA divided by x squared plus to the power 3 by 2.
फिर से बोलो.
Huh?
Repeat.
So mu naught IA divided by x squared plus a squared to the whole power 3 by 2.
There are two mistakes. First of all, it is a square, and there is a 2 in the denominator.
Oh, yeah. So yeah, it'll be mu naught IA squared. Okay. Yes, sir. I remember that.
Solenoid magnetic field inside a solenoid.
Magnetic field inside a solenoid.
Are you kidding me? You don't know magnetic field in a solenoid. You have given all previous answers.
So what?
You have given all the previous answer and you don't know what is the magnetic field inside a solenoid.
So I forgot.
Wow. Mu naught Ni, fifth answer. It's mu naught Ni, fifth.
Magnetic field induction with distance. So it's the first one.
Oh, wrong. It's fourth one. It is mu naught I by 2 pi r.
The R is the radius of the wire, right?
No, r is a distance.
Oh.
It's a thin
No,
wire.
R is the radius of the wire.
Sixth.
So T by 2.
Wrong, it's T. Time period is independent. It is 2 pi m
Oh,
by
the
QB.
velocity. Oh, yeah.
Seventh.
One minute. So I'm not too sure about this one. Will it be east?
That's correct. East is correct. Eighth.
So will it be option 4?
Did you work it out?
Yes, sir. So the magnetic dipole moment due to the bigger loop, which is 2r, will be 4ir squared. And
4ir square. Why is that to be 4ir square?
So it'll be I. Oh, sorry. Oh, I forgot to say areas wrong. So 1 minute. So option 1.
Correct. Good. What is the value of one Bohr magneton?
1 Bohr magneton is so I forgot this.
14th.
Oh, the dots. So proton.
Correct. Good. Last 17th. This is the last question. Okay. Also, I have sent a link in the group in your Zoom chat. Open it. Okay. And
Yes, sir.
you have to write all the numericals in this. Okay.
Okay.
And send me.
So by when?
That is homework.
Yeah. So when is it?
1 month.
Next class?
Yeah.
Okay.
This weekend you have to do it. Okay.
Yes, sir. So 10 ohms, option 2.
10 ohms.
Yeah.
2. Oh.
So on
10%. That means I is going through
I
the
by
galvanometer,
10.
and 9 I is going 10% is
That
I
equals
is
I
going,
by 10 and 9I by 10.
yeah, that's fine. I by 10 is going through which one?
The galvanometer.
The galvanometer, yes. So
So it'll be
I by
I
10
by
into
10.
99.
Yeah, equals 9I by 10 into shunt resistance.
X, yes. Now the only thing you can do mistake is simple maths.
Oh yeah,
Calculation.
I did the math wrong.
Okay, that means it's fine. Your this concept of galvanometer ammeter is also fine. Good. Your VIVA was good, except a few things. Okay, fine. Okay, you can leave.
Okay, thank you, sir.
A charged particle is going in a magnetic field. Is moving in a magnetic field. Okay.
Second, sir. I want to remove my earphones. Yeah, you can.
A charged particle is moving in a magnetic field, but is not suffering any deflection. Why?
A charged particle is
moving in a magnetic field, but is not undergoing any suffering any deflection. Why?
Um,
What is the Lorentz force ka formula?
F is equal to Q into E into R. Okay, E plus V cross B.
Repeat it.
F equals to Q square bracket E into in the textbook it's written E into R plus V cross B into R square bracket close.
Okay. What is the formula for radius when a charged particle is moving in a magnetic field?
R equal to MV by QB. MV by QB.
That's correct. An electron and a proton are entering a magnetic field. Okay, everything else is same, just that they're electron and proton. Whose radius will be more?
Electron.
Are you using your common sense? You said the formula correct. Now you're saying electron will have larger radius.
Can I do it and see 1 second? Can I do it numerically?
Yes, do it, do it.
Okay.
Tell me what are you doing? What are you doing? Okay.
So I'm putting mass of electron and charge of electron and mass of proton and charge of proton in the formula.
Are you actually putting numerical values?
Yeah.
I'm just asking you which is more. Do you need to put numerical values?
So it will be proton then.
Yes. Yes. What is the force between two parallel conductors carrying current I1 and I2?
Wait, can you repeat? So you're
force between two parallel conductors.
Yeah.
Separated by a distance d carrying current I1 and I2. The force per unit length. The formula. What is the formula? It's a direct formula.
Yeah, I don't remember it.
And why is that so?
I think I know it, but I don't know if it's right or wrong.
Speak.
Mu I1 by 2 pi r.
Repeat.
Mu of I1 by 2 pi r. Mu of I1 I2 by 2 pi r.
Mu of
I1 and I2 into I2 multiplied by 1 to pi r.
That's correct. If the wires are having the current in the same direction, will they attract or will they repel each other?
They'll attract.
Correct. Using this formula, the one mu naught I1 I2 by 2 pi r, how will you define 1 ampere of current?
Define 1 ampere of current.
Yes.
With relation to this one only, or can I tell normally also what 1 ampere is?
No, with relation to this only. Because this is what in the chapter is. It is there. The definition is given. I've taught also. I remember.
So it is 1 coulomb of electrical charge moving past the wires, moving past in a specific point in that second in the 2 wires.
Bus. By Wood's law in vector form.
Mu naught by 4 pi into I dl sine theta by, oh wait, in vector form, right? So I dl by r square.
In vector form.
Yeah. If you remove the sine theta, it will be cos.
अगर वेक्टर में तो क्रॉस प्रोडक्ट आना चाहिए ना?
Yeah.
क्रॉस प्रोडक्ट तो नहीं बोला तुमने?
I cap.
The answer is mu naught by 4 pi I dl cross r by r cube.
Was that in the textbook?
Yes, it is in the textbook.
Okay.
What is magnetic field inside a solenoid? The magnitude.
What, sir?
What is the magnitude of magnetic field inside a solenoid?
Oh, no. Two 2.9 into 10 to the power minus 5. Wait, 8.505 into 10 to the power minus 4.
There is a solenoid carrying current I having n turns per unit length. What is the magnetic field inside it?
Yeah, 8.5 into 10 to the power minus 4.
What are you saying? Mu naught Ni.
You asked for magnitude, right? So the number.
So it is mu naught Ni.
Okay,
have I given you current in the solenoid? Have I given you number of turns per unit length? No, then how can you tell me there is a particular numerical value?
Because I saw it. Okay, fine.
No, it's not fine. You are not giving me easy answers. What is magnetic moment? You can tell me the formula of magnetic moment also.
M by 2L.
Magnetic moment of a loop of a current I area A having n turns?
N into L into A.
N into I into A. What is the unit of magnetic
It's
moment?
length into area, right?
No, it is
Number of turns into the length into the area.
no. It's current into the area IA into number of turns. NIA. What is the unit of magnetic moment?
Ampere meter square, ampere meter square, right?
Correct. What is the unit of, okay, in a moving coil galvanometer?
In a?
Moving coil galvanometer, MCG.
Yeah.
What is the peculiar thing about the magnetic field? Anything special?
Moving coil. Wait, can you repeat?
In a moving coil galvanometer, what is the peculiar oblique special thing about the magnetic field used or the magnets used?
A permanent magnet is used?
Yeah, a permanent magnet is used. That's correct. What is the specialty about the magnetic field lines which are used or the magnet which is used? Any particular shape? Have you read the book once?
Perpendicular. It's perpendicular. What?
To what? It's perpendicular to what?
Wait, what is your question?
Okay, you tell me it is perpendicular to what?
The magnet is perpendicular to the magnetic field.
The magnet is perpendicular to the magnetic field.
Yeah.
It is a radial magnetic field. It is always perpendicular to the area. You have not read the book, right?
Not fully.
You knew that there is a VIVA. I have like 3-4 days to prepare. How is torque and deflect theta? Theta is the deflection. Torque
How is torque?
Torque related to deflection.
So wait, I'm just gonna put my earphones.
In a MCG.
Yeah, can you repeat? I put my earphone. How is torque what?
Related to deflection. In a MCG. No need to tell the exact relation. You can just tell me in words how are they related. Can you see the screen?
Yeah.
Question number 5.
2.
Hello, yes. Yeah, what is the answer, Opal?
I told 2.
You don't know?
I told 2. 2.
2. Oh, 2 is wrong. How can it increase with radius? I mean, if you go away, the magnetic field can't increase. So 1 and 2 are of course not the options. It's 4 because it's mu naught I by 2 pi r, the formula. 6th. Speak loudly, okay? I'm not able to hear.
Uh, 4. T.
Hmm?
T. 4.
That's correct. A reason?
Can you go back?
Reason. Speak loudly.
Okay, I'll tell. Wait 1 second.
Can't hear you.
It's 2 pi r by T, right? So we put that formula. And
Hmm.
we got T equals to 2 pi m by Q into B.
Correct, very good.
Time period doesn't depend.
7th.
East.
Pardon? Yes, it is easy. Please answer.
Sir, I said east.
Okay, east. That's correct. 8th. You can tell me how to do it and that will be fine. No need to actually tell the answer.
Okay.
Speak loudly, but.
which sir I'm doing it actually.
Okay, okay, it's fine. I'm giving you a question on the. You do it, okay? And after you're done, hello.
Yeah.
You just tell me the final answer, okay, of both the parts. See the Zoom chat. Hello, Akshat. Hello, Akshat.
Yeah, 1 second. Yeah, please. Subjective. Sorry. They're going to be MCQs only, right?
Yeah, MCQ. I'm VIVA oral VIVA. Okay, so okay. Okay, questions. Radius of a charged particle going in a magnetic field. Formula.
Radius of a charged particle moving in a magnetic field. 1 second.
Formula.
So, yeah, B will be. I'm not sure.
Okay. A charged particle is going in a magnetic field. It is moving, but it is
Yeah,
not suffering any deflection.
it's moving, but it's not suffering any deflection. Okay.
Why?
It's moving in the same line as the magnetic field, like
Correct.
parallel or anti-parallel.
Correct. Good. Why you don't know the first question?
I don't remember the formula. I'm very bad with the formulas. It's
Very funny,
something. It'll be mu naught dB something mu naught pi by 4
You know your
pi
way of
r
the mark.
cube. Wait, I can calculate it, but I can't remember.
Your way of the mark.
Way off. What's the answer?
This is exactly, if you don't know the radius, you will not be able to answer many of my further questions. So I can't ask you all the further questions which I was going to ask, because you don't even know the basic formula for radius. If I ask you, an electron and a proton are going in a magnetic field, which will have a larger radius?
Wait, proton and
electron.
They
have the same velocity.
Oh, I think it's proton, right?
Why?
I don't remember. I don't have a reasoning, but I think it's proton.
Okay. When will a particle go helical motion? What is the condition?
What motion?
Helical motion.
Helical, like, okay. Oh yeah, when the what do you say, velocity is perpendicular to the magnetic field. Helical, right? Circular. Yeah.
Helical is circular.
Yeah. I mean,
circular is circular. Helical is circular plus a translation.
Oh,
like your DNA.
Okay.
You didn't prepare, right?
I didn't get time yesterday. Only today morning I prepared.
When was the message put?
I think Wednesday we decided. Tuesday we decided this.
Monday.
But physics, okay, on Monday maybe. So
Today's
Tuesday,
Friday.
Wednesday. Today is not. Oh,
today's Friday.
okay.
Monday evening
Yeah.
6:24 पे I have put the message.
Maybe we decide.
Monday है तुम्हारे पास, Tuesday है, Wednesday है, Thursday है. आज का भी दिन है, 3 बजे तुम्हारा वाइवा है, मतलब 3 से पहले पूरा आज का दिन है. छुट्टी है, आज भी छुट्टी थी, कल भी छुट्टी थी. मुझे रेडियस का फॉर्मूला तुमको नहीं पता है. बायोट-सेवर्ट लॉ बोलो वेक्टर फॉर्म में.
Be dB mu naught by 4 pi I dl cross r by r cube.
Okay.
Or you can take the sine theta one also.
Sine theta is not in vector form. The first answer is correct.
Okay.
The force per unit length between two parallel wires carrying current I1, I2 separated by distance.
Sorry, 1 second. 1 second. Sorry, yeah, what?
Force per unit length between two parallel wires carrying current I1 and I2 separated by distance d.
I1, I2 parallel conductors.
Yes.
Their parallels will be attractive and Pearl and DL, right?
Yes. Formula.
I think it's IB. If it's F by L. I think it's IB sine theta. IB sine theta.
Bus. Can you, of course, the next question is, can you define 1 ampere of current using this formula?
1 ampere of current.
1 ampere of current, yes.
Can you define it?
No, define 1 ampere of current using the formula.
Okay, 1 ampere. F is in terms. No, I don't. But this angle also, I'm not sure.
What is the principle of MCG?
MC?
G, moving coil galvanometer.
The principle. I don't know the principle. I can tell you how to convert them.
No, I'm not asking you to convert galvanometer to ammeter and voltmeter. I'm asking you, how does a galvanometer work?
How does a galvanometer work? I'm not sure.
Okay. This is hopeless. Tell me what you have studied.
I don't know. I tried studying everything, but I don't know if I remember anything.
What is a magnetic moment formula?
Magnetic is magnetic moment, right? That's NIA. Yeah.
Unit.
Unit of magnetic moment. It'll be so N number I don't know. I think it's ampere to current. I don't know.
You just said the formula correctly. Now you can't tell me the unit correctly.
It'll be N is just a number, so it'll be. Is it coulomb meter square?
What is I and A?
I is current, A is ampere. Sorry, A is area.
Then what is the unit?
It'll be coulomb meter square.
Coulomb meter square. A current ka coulomb.
Sorry. Ampere meter square. Ampere meter square. Sorry. Ampere meter square.
There is a circular single loop, radius A, carrying current I.
What? Sorry, what?
Circular loop, radius A, carrying current I.
Okay.
At an axial point of a distance x from the center.
Okay.
There is a point P.
Point P.
Yes.
Yeah.
Tell me the value of magnetic field at this point. Make the figure also and tell the formula also. Figure banao.
Okay,
paper
so wait, this point P is on the axial point.
हाँ, वो figure बनाओ
so
paper
the
पे.
figure.
और मुझे वो formula बताओ कितना होगा magnetic field वहाँ पे.
It should be dB.
नहीं,
dB.
पहले figure बनाओ.
Okay, figure.
Opal, are you done with that numerical?
Yeah, sir.
Tell me the answer in one word answer of both parts.
Oh, should I not send the picture?
No, tell me just the answer.
Oh, first part is 0.2 ohm. Second part is 0.016 ohm.
Oh, it's 0.16. Okay, fine. You can leave.
Okay, fine.
Wait, you want me to make the forces also?
I also got.
No, I just want बस एक figure बनाओ. Okay.
Give me 1 second. I'll make the forces also.
नहीं, मुझे derivation नहीं चाहिए. मुझे सिर्फ वो figure बनाओ और मुझे वहाँ पे magnetic field का net magnetic field का value बता दो ऐसे. Figure दिखा दो screen पे.
dB will be mu naught. Okay,
Figure
so it will be. Okay, figure.
Radius A है, radius ठीक है. चलो R लिख लिया, कोई बात नहीं.
Sorry, I just wrote it R.
ठीक है. Current I है, मुझे magnetic field value बताओ वहाँ पे कितनी है.
So dB will be mu naught.
dB नहीं चाहिए. dB small magnetic field. I want the net magnetic field at point P.
Net, right? Oh. Net. It'll be B is equal to mu naught 4 pi by.
No.
I'm not sure the net magnetic field formula. I know for the element, not the net. Will be something ideal by.
No.
I think it's wait. I think it's mu naught Ni by 2R. I'm not sure.
Let it be. Fifth का आंसर बोलो. सामने जो क्वेश्चन.
Distance due to thin. magnetic field will be option 4.
Correct.
Yeah.
Question 6.
Hello.
When an electron enters.
Opal, you can leave.
No, sir, I was saying that I got the answer for the previous one that you had asked.
What?
That let it be.
Okay,
Leave.
fine, bye.
T is the this for like cyclotron, right? There time period shouldn't change with velocity.
Correct. 7.
Positively charged falls vertically downward. Horizontal component is formed. Shit, I don't remember which direction it is.
You don't know which direction is horizontal
The
component.
earth, I know the vertical. Okay, wait. 1 second, 1 second. It won't. They'll be parallel, right? Because it's falling downwards.
In which direction is the vertical horizontal component of Earth magnetic field at any point?
It'll be from south to north, right?
In which direction is the particle falling?
Falling down, that's like third dimension. So it'll deflect it towards north. It's south.
Eighth.
What is the answer though?
Wrong है उसका east है answer. 8th बोलो.
East.
उसका ये 8th बोलो. कैसे करना है वो बताओ.
Magnetic dipole. So magnetic dipole given by NIA. So, but there are 2 loops here. So I think we'll calculate them one by one, and they're half loops. So n will be half. It will be half I will take constant, half I pi r square plus half I 4 pi r square.
Do you add these 2 values or do you subtract these 2 values?
Wait, one second, I'm seeing that only. One's going in that direction, the others. You'll add them. Oh, wait, they're in opposite directions, so you'll subtract them.
Are they opposite or same?
They're not same, right? The circular loop is going from east, west, sorry,
nice.
west to
ऊपर वाला
east.
clockwise है कि anti clockwise?
ऊपर वाला clockwise है.
नीचे वाला?
That's also clockwise. I was thinking the other way. 1 second. So it'll be 5. It'll be option 1.
That's correct. Your answer is correct. Although there was one mistake. You said n is half. N is not half. The area is half. N is 1 only.
Okay, but okay, that's I still got the same answer. Okay.
$41.
The current I flows in circular loop whose radius r is magnetic induction. I don't know the formula. I can guess, but I don't know the answer. Hello?
Yes.
Yeah, I said I can guess, but I won't know the correct answer. Like I won't do it. I don't have a reasoning. I don't know the formula. That's why.
Can you guess? It's easy.
3 by 5, 2. I don't know. I'll probably guess the only one which has 3, which is 4th option.
I think it's correct. Yes.
Oh.
Because there should be, it is 3 pi by 2. It is 3/4 of the formula. There should be a 3 in the numerator.
Yeah, that's why I chose that one.
The formula is mu naught I by 2r for a full circle.
Not I by 2r.
For a full circle.
Okay.
If it's 3/4 of a circle, you multiply by 3/4, you'll get 4.
Yeah.
You have surprised me today.
I didn't get a chance to study at all. Yesterday, whole day I was at home also. Okay, magnetic. This one are we doing? Yeah, and this they are opposite directions. It'll be first one
Correct.
because R1's bigger.
Write the expression for Lorentz magnetic force on a particle of charge Q moving with the velocity V in a magnetic field B.
Electric field.
B चलो ठीक इलेक्ट्रिक फील्ड भी है अब बताओ.
Electric field.
B है, there is electric field also.
So it'll be Q into B plus B cross V. Q is a whole.
V cross B.
Yeah.
V cross B.
Oh, I said B cross V. Oh. Yeah, V cross V. V cross V. All right.
What is the magnetic value of magnetic field inside a solenoid?
Value of magnetic field inside a solenoid is mu naught Ni. Yeah, mu naught Ni.
What is N?
solenoid and toroid?
What is N?
Number of turns.
Are you sure?
Yeah, this can't be anything else.
Number of turns per unit length.
Okay, number, but still number of turns.
No, they are different.
Okay,
things.
fine. Number of turns per unit length.
A square, there is a square of radius A, side A,
Okay.
and a circle of radius A.
Yeah.
One loop only, one turn.
Sorry, what?
There is one turn only. Number of loops is one. Both
Okay,
of them.
okay.
Which has and same current.
Yeah.
Which has more magnetic moment.
Magnetic moment, right? A square by R square. Yeah, it'll be the sorry. This will have more the circle.
Why?
It has this because it has a bigger area.
Okay, correct. So you are okay with numericals, but you have not read any theory. You have not studied anything.
I just read through all the formulas and stuff. I didn't get time.
Okay, you tell me this question 1 second. See Zoom chat. Tell me this answer.
Ammeter. Yeah, I don't think I remember the shunt meter formula. If I knew it.
I have done at least 10 questions in the classroom of this concept.
Yeah, but I don't remember the formula.
So then why are you attending the classes and all this? Why all this is happening? If you don't understand, everyone has answered this, pata? Everyone has answered.
Yeah.
Open this link.
Yeah.
You have to write all the answers in this link and send me by weekend.
Yeah, I was doing this one today morning only. Okay, fine.
Right.
Yeah.
Okay.
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 Fine.
Fine. Leave. Okay. Bye bye.